Welcome to the AI Research Roundup. I am Alex. Today, we're looking at a paper from the Papers with Code trending list, published on May 24th, 2025, called ChartGalaxy, a dataset for infographic chart understanding and generation. This paper introduces a massive new dataset, ChartGalaxy, with over 1 million examples. It's designed to help I better understand and even generate complex infographic charts. These are charts that combine data with other visual elements like images and rich text. The challenge is that current large vision language models, or LVLMs, which are advanced AIs designed to process and relate both visual information and text, are often trained on much simpler, plain charts. ChartGalaxy aims to improve these models through fine-tuning and also helps in creating new infographic charts. Alright, and as is often the case with these exciting projects, the authors have also shared the code for this work. So if you head over to their ChartGalaxy repository on GitHub, you'll find things like the code generation benchmark, which is essentially a standardized test to see how well AI models can actually write the programming code needed to create these infographic charts, along with example scripts and instructions to get started. So Figure 1 in the paper really gives us a nice visual summary of ChartGalaxy and its impact. It shows the dataset itself, over 1.1 million synthetic and over 100,000 real infographic charts. Then, it highlights 3 main applications. First, for infographic chart understanding, we see how training models like Intern VL38B and QN 2.5 VL7B with ChartGalaxy significantly boosts their performance on several benchmarks. Second, for code generation, it ranks different AI models on creating chart code, with Gemini 2.5 Pro scoring highest. And third, for infographic chart generation, their method produces charts with better fidelity, aesthetics, and creativity than GPT Image 1. Alright, so to achieve all that, Figure 2 gives us a look under the hood, showing how the ChartGalaxy dataset was actually constructed. It outlines 2 main pipelines. For collecting real infographic charts, they crawled the web, removed duplicates, then filtered the data and extracted tables, resulting in over 100,000 real examples. For the synthetic chart creation, they started with 75 chart types and 330 variations, combined these with text and images, and then applied one of 68 layout templates, which are pre-designed structures for arranging all the visual elements, to produce over 1.1 million synthetic charts, each paired with tabular data. Okay, so after seeing the creation process, Figure 3 gives us some concrete examples of these synthetic infographic charts from ChartGalaxy. We can see a real variety here. Different chart types like bar charts, line graphs, and what look like custom visualizations, each with unique visual styles and topics. For instance, there's one about top wine exporting countries, another on new energy vehicles, and one showing global freshwater reserves. And importantly, each example also shows a little icon representing the underlying layout template that was used to arrange all its elements, connecting back to those 68 templates we talked about earlier. Now, Table 1 really drives home the point about improving infographic chart understanding. It shows us the performance of 2 models, Intern VL38B and QN 2.5 VL7B, on 2 public benchmarks called Infographic VQA and ChartQA Pro. What's clear is that when these models are trained using ChartGalaxy, their scores jump up significantly. For instance, Intern VL38B improves by almost 6% on ChartQA Pro, and QN 2.5 VL7B sees a boost of over 4% on Infographic VQA. This really demonstrates the value of ChartGalaxy for enhancing how well these models can interpret complex visual data. Following on from those public benchmark results, Table 2 digs even deeper. This table shows performance on an independent evaluation set, a fresh set of test data, giving a strong measure of generalization for Intern VL38B and QN 2.5 VL7B. The results are broken into categories like text-based reasoning, visual element-based reasoning, and visual understanding. The overall improvement is really striking. Intern VL3 jumps by nearly 27%, and QN 2.5 VL by almost 24%. The biggest leaps are in visual understanding tasks. For instance, detecting chart styles improved by over 60%, and analyzing visual encodings, which is how data is visually represented, saw gains of over 40% for both models after training with ChartGalaxy. Alright, so ChartGalaxy isn't just for understanding charts, it's also a great resource for generating them. Table 3 demonstrates this by comparing 17 different large vision language models on their ability to create D3.js code. That's a popular library for making web-based visualizations from ChartGalaxy images. The table reports an execution rate, basically, does the code run, and then a low-level score, which checks how well the generated chart matches the original in terms of specific elements like area, text, and color. There's also a high-level score using GPT-4o to judge overall visual similarity, and finally, an overall score. Looking at the results, Gemini 2.5 Pro comes out on top for proprietary models with an overall score of 85.21. And interestingly, among the open-source models, Llama 4 Maverick 17B performs best with 61.29, even beating some of the proprietary options. This really highlights ChartGalaxy's utility as a benchmark for this kind of code generation task. Alright, so we've seen how ChartGalaxy helps with understanding and code generation. Now, Figure 4 really illustrates its power for creating new infographics. This figure shows 3 distinct examples, each in a row. In each case, panel A is the reference infographic. Panel B is what GPT Image 1 produces when trying to adapt that style using the same underlying data. And panel C shows the result from the author's method, which leverages ChartGalaxy. You can generally see that the charts in column C, the R's column, maintain higher fidelity to the original style and layout, and often look more aesthetically pleasing and clear, effectively using those layout templates and chart types we talked about. This visual comparison really supports their user study findings about improved generation quality. As we've seen, ChartGalaxy really offers a robust framework for both dissecting existing infographics and, as Figure 4 showed, generating new, high-quality ones. It's a significant step forward, providing a rich dataset and a strong benchmark that can help advance AI's ability to work with visual data representations. This kind of work is crucial for making information more accessible and for unlocking new creative possibilities in how we communicate data. Well, that's all for this AI Research Roundup. Thanks for tuning in. I'm Alex.